How's everybody doing? Good. Awesome. It's a little early in the morning, but we're going to have a lot of fun at the party tonight. I will be the DJ, so I hope you guys can make it. With that said, let's go ahead and get our next speaker up here. Ladies and gentlemen, I present to you Andrew Widdersheim.
Hello? Can anybody hear me? Okay, cool. All right, so the title of my talk pretty much embodies like the worst case scenario for me on any given day. Nagios going down is very bad. For me, I'm primarily responsible for the Nagios install for where I work. So anytime it goes down, I have to go see my boss, and I don't like doing that. So this picture kind of embodies, however, whenever this happens, this is kind of how I feel. And I'm hoping that some people can at least sympathize with me on this one. I'm not the only one that has had something go down. Maybe it wasn't Nagios, maybe it was something else that you're responsible for. But it's probably the worst feeling in the world to get that like pit in your stomach. And Nagios, and things never go down the way you want them to, right? It's always New Year's Eve, you're drunk, you're hungover, and everything that could have gone wrong went wrong, and you're spending the next 8 hours trying to get your server back online with your boss just hovering over you, asking you when it's going to be done. So we want to try and avoid that situation. This talk is really about trying to minimize the chances of that happening. And the way we'll end up doing that is we'll try and create a like an active, passive, highly available failover cluster. And then once we have our cluster online, we still want to be able to update and make changes to our install without affecting anything in production at the time. And then finally, the other big thing that we want to do is make sure everything's running well, right? Like Nagios, needs to run fast, and it needs to be doing its checks in the proper amount of time. So we're going to try and get to all those things all in this one talk, because I'm not sure if you guys have heard, but Nagios is kind of a big deal. We're obviously all here at this conference, but I was able to come to the conference last year, and the people that you talk to, everybody, you get the feeling that Nagios is an integral part of people's businesses now. Like they're setting up Nagios boxes to watch things that are important to them, and when it goes down, they're basically blind to the things that might be happening. So to use my company as an example, I work for a managed hosting company called iNetU. We're based out of Allentown, Pennsylvania, and we basically attract the clientele that want to offload some of the IT stuff that they wouldn't be able to handle themselves. Or they just want to be able to focus on their business and not have to worry about some of this stuff. So that ranges from things, so we own and operate our own data centers. So we house their equipment properly, and we can replace hardware if it goes down. We have 24/7 support staff that they can call and ask questions to, or that can respond to issues if any arise. And then, of course, we do monitoring, right? Monitoring, as many of us know, isn't really the simplest thing, right? Nagios can be a complicated piece of software, and it's difficult to set up, it's difficult to maintain, and it's difficult to get right, but it's important. We need to know when their stuff is down, our client's stuff is down, the clients want to know when their stuff is down. And when Nagios isn't running, we're basically blind to anything that might be happening. We use Nagios in a very typical way. We watch our servers, we watch our network infrastructure, we watch our data centers. So there's just too much to keep track of without Nagios. So we have to keep it up. So then we start to look at Nagios high availability options. And this is actually just a short list. I really kind of just wanted to highlight the fact that there's more options out there than the one that I'll be talking about. So I highly recommend going out and investigating these options for yourselves to see the pros and cons of each. And the other thing that I want to say is I'm by no means an expert in any of these. Luckily, we're at a Nagios conference where there's plenty of experts that you can find. So for instance, Merlin by Op5, I'm pretty sure the Merlin developer is going to be giving a talk later in the conference about Merlin. So highly recommend checking that out. The second one in the list is the classic method or model. It's kind of just the name that I gave it. But if you go through the Nagios core documentation, there's basically a bit of a blurb on like how to set up a high availability scheme. I think there's a talk going on right now about how that might work with XI. I talked to the guy last night, and basically, it's just a set of scripts to have a passive and active node, and it'll fail over, but you keep it in sync with NSCA. So after the talk, definitely go check his video out. And then the third option is using some kind of virtualized solution. Like the most common example is you put Nagios on a VMware machine and use vMotion. You know, the virtual machine that Nagios is running on, there's a problem with the host, so you use vMotion to move that virtual machine over to another host that isn't having that same problem. So those are, I mean, again, very short list, but the method that I'm going to be mostly talking about today is using Pacemaker and DRBD. And this pairing of software has kind of become a standard with Linux HA, and it's been used in thousands of places to make tons of things highly available. That's the really cool thing about these two pieces of software is it's completely agnostic to what you put on top of it. You know, you could put NFS on there, you could put MySQL on there, you could put Apache on there. You know, so why not put Nagios on there? Just because we're trying to make Nagios highly available doesn't mean we have to start writing 1,000-line shell scripts and neb modules. You know, we can use the software that other people have written to do this very same thing and get it up and running very quickly and know that we have a reliable cluster. The other cool things about these things are these two pieces of software. They're all open source. They're all free. They come with a great community. Like the mailing lists are super active and really good documentation for all these things. So let's talk about what each of these things are. And we'll start with DRBD because to me DRBD is basically it's the workhorse of your cluster. It's the thing that's going to keep your data in sync between one node and the other. And it basically does it with what I call magic, but it's not magic. It's, you know, just straightforward. But the way DRBD works is it actually lives inside the kernel, and it can get there in two places, or in two ways. The first way is you build and install a kernel module, or the second is in the later releases of the Linux kernel, you can the DRBD code is actually within the mainline Linux kernel now. So you just basically activate it. It's much easier if you can get to the latest releases of the Linux kernel and just use it that way, because it makes updating the kernel much easier from then on, than forward on. Yeah. But if we look at the diagram that I blatantly stole from DRBD's website, each of these peach-colored rectangles is basically their own server, right? You can completely separate these and have them run on their own independently of each other. They both have their own set of disks, and they both have their own network card. But the way DRBD works is, we'll say that the peach-colored thing on the left is our primary server at the time, and our on my right, your left, yeah. The peach-colored server is the primary at the time, and the other one is our secondary. And as we're doing writes to our disk, as it would normally, DRBD is going to sitting in the perfect place in the kernel to say, hold on, wait a second. Before you write that data, let me go ahead and send that over the network to my other partner here so he can also write that same data. And we're doing that at the block level. So we're basically replicating our block devices over the network. And it's doing that in real time, like very, very quickly with little overhead. Only the overhead of the network and what your disks are is the only thing that's going to slow that down. So really cool. Again, it's free. It's developed by a company called Linbit. They are the main maintainers of DRBD. And kind of cover all the stuff that I've already covered here. You know, runs in the kernel. I mean, the DRBD has a laundry list of features. I definitely recommend checking it out. Like the use cases for DRBD they extend way past this. You can use DRBD for a ton of things. It's really cool. But there are some considerations when you start to look at setting up a DRBD cluster. And the first thing I have on the list is really that DRBD is only going to be as fast as your slowest node. And what I mean by that is, you know, typically when you're setting up a high availability cluster, you don't want to just buy a super powerful server that you're expecting to always be running on, and then kind of stinge on your other node, because the idea is you always want to be able to run your resources on any node at any given time without any repercussions. The other thing is, the way DRBD works is depending on what protocol choice you use, which I have down a little bit further. Typically, we run in protocol C, which means it's a synchronous replication. So when you're writing data, the I/O is only reported as completed from DRBD back to whatever is actually writing that data when both nodes have written to its disks, right? So if you buy your primary nodes stacked full of SSDs and it can power through I/O like nobody's business, but you just buy your other node, which is commodity SATA drives, and it can really just kind of chug through that much slower, the other node has to write that data before we say that it's okay, before we can continue on with the next I/O operation. So definitely try and get your two nodes at an equal playing field as far as hardware goes. The other big thing is network latency. So as I mentioned, like all the replication happens over the network. So depending on how far you might be sending this data, like geographically, and what kind of link you're using, you might have to take this into consideration. Like you can easily replicate over great distances. It's just that you have to account for the latency between the two places that you're replicating to. So there's some really good documentation on DRBD's website about like how you can measure this. The next thing is there's some stuff that you can do to even speed this up with like DRBD proxy and doing some network stack tuning. DRBD proxy is actually a paid-for product put out by Linbit. What we do, and what I would recommend doing if it's possible, is just set up a dedicated crossover link for all of your DRBD communication. So that's like the fastest possible way that you can replicate your data, right? Like direct crossover link, and we're lucky enough to have our own data centers so that we can just do that between data centers. And then, of course, I have protocol choices down here. Like I said, we normally run in protocol C, which is all synchronous. Like data has to be written to both disks before we say that our data is actually written. Whereas some of the other ones will return that completion much sooner in the stack of things. So like protocol A is obviously going to be your fastest because all we have to do is write to our local disk, and then our I/O operation has to make it to the TCP buffer to send to the other node, and then we're okay. So the next thing we have is pacemaker. So if DRBD is the workhorse, pacemaker is basically the brains. It's the thing that's going to tell our cluster what resources we're running, where they should be running, what should happen if a node fails, what should happen if a resource fails, are we monitoring our resources? We can do resource level monitoring within pacemaker. We can say, make sure the Nagios process is running, and if it's not running, try to restart it or try to fail over to the other node. It'll do all that for us, and pacemaker is actually really configurable. It's able to do huge clusters. We're only doing a 2-node cluster in our example, but it's capable of doing much more than that. And this is a diagram of what's often referred to as like the pacemaker cluster stack. And obviously we have our 2 nodes that we're going to be running everything on. And above that we have a messaging layer. And the messaging layer is actually filled in by two different pieces of software that you can choose from. The first is, I'll cover Heartbeat first because Heartbeat's kind of fallen to the wayside. It's not really developed anymore actively, and I wouldn't recommend using it just for that fact. It seems like CoroSync, the other option, is now under development. It seems to become the new standard for what people are using as their messaging layer. We actually use Heartbeat because that was what we were familiar with when we first set up our cluster, but if I were to go back again, I'd probably use CoroSync. And then finally we have Pacemaker. Like I said, the resource manager, the thing that's going to make all the decisions for us. So I'm a visual guy, so we're going to try and put it all together in like one view here to see what it kind of looks like when you're done. And obviously we have our Pacemaker cluster stack running on both our nodes, and then we want to start piling on all the things that we want to get Nagios to run. So first thing that we need to do is we need to start up DRBD, and Pacemaker is going to decide which one's primary and which one's secondary. And then once we've decided which one's primary, that's when we're going to start all of our other resources up. So the next thing we can do is mount our file system, which is where we can write our data to. That's going to get synced between our 2 nodes. And then obviously we have our virtual IP address that's going to float between the 2 nodes, and then all the rest of the Nagios stuff, right? Because Nagios to me isn't really just one thing anymore. We have NSCA, we have MPCD, we have Apache, we have the actual Nagios process. All these things have to start, and sometimes they have to start in a certain order. So Pacemaker is going to do all that for us. And then in the event that something goes bad, like node 1 dies, or we want to fail over so we can do hardware maintenance, we're just going to go ahead and stop everything in the same order, and pacemaker is going to go ahead and make all the decisions and start up our primary on the other node and start up all of our processes for us. And that's pretty much what it looks like when you actually fail over, if you look at the cluster or the pacemaker configuration manager. But I do have to say, this slide's not going to be helpful now, but maybe when they release the slides online. This is kind of just a snippet of what our pacemaker configuration looks like. And pacemaker configurations are kind of difficult to tackle at first, kind of like Nagios, right? Like you have to do a few things in it to really get like a good feel for what you need to do. But we'll kind of go through some of the things that you have to do within pacemaker. And basically, the first thing that we'd want to do when we get into pacemakers, we want to set up a primitive. And a primitive in pacemaker terms is basically a resource. And this particular resource, we're going to call it PFS Nagios. So we're just going to give it a naming scheme. And this is actually going to use, so pacemaker and heartbeat ship with resources or resource scripts that you can use to run in your cluster. This one's just the OCF heartbeat file system script. And we're going to pass it a couple of parameters. We want it to mount this particular disk or block device that it sees, and we want it to mount it to /drbdr1. And we want to tell it what file system type we're mounting it as, and any options that we might want to pass to it. So we're basically just mounting our file system with this. This is how we're telling pacemaker how we want our file system to mount. And then there's some other options here, like the start and stop interval. This is basically telling pacemaker how long is it okay to be starting this, and at what point is it that we've started something and it hasn't actually started, that we should decide that this has failed and that we should maybe do something else. And of course, we want to monitor our file system. Pacemaker is going to go and run a monitoring operation on our file system using what is in this script to make sure that our file system is up and running and operational. And if it's not, for whatever reason, it's either going to try and remount the file system, or it's going to try and fail over to the other node and see if we have any more luck over there. The second one is basically the same. It's another primitive. This one is for the actual Nagios binary that we're going to start to run using the LSB, your everyday init script. And it is, again, we're setting a start and stop interval, basically saying how long is it okay for it to be in a starting state and in a stopping state before we time out. We also want to monitor this, right? We want to make sure Nagios itself is running every 30 seconds. And if it's not, we'll do something about it. And then finally, we're just saying, I want this to be started whenever my cluster comes online. And finally, we get to a group. A group is basically a group of primitives. Like this is all the things that we want to start on a single node whenever we pick our primary in our cluster. We want all these things to start, and the thing about groups is they all start in this order too. So it's going to start the file system for Nagios. It's going to start, or it's going to bind the IP. It's going to do that in that exact order because you need it. Like you can't start Nagios without our file system, right? Like that has to exist before we can do anything else. And then it'll also stop it in that order, and in the inverse of what you set up here. And again, we're just saying we want this to be started. But after you get all that done, you kind of end up with this really cool cluster that you can have a lot of fun with, and will keep you partying on New Year's Eve. You don't have to go see your boss, hopefully. But there are some things with pacemaker that you have to consider, just like DRBD. And the first is you have to have redundant communication links. If you can't achieve that for whatever reason, I would not recommend setting up a pacemaker cluster. And basically the way that we do this, again, is we do communication outside, like our front-end interface, through our switches, and then we have a dedicated crossover link again to do the communication directly through that crossover link. So if for whatever reason our switch goes down, we still have that crossover link to maintain like cluster stability. The other big thing is the init scripts for Nagios must be LSB compliant, and some of them aren't. Basically what that means is if you Google pacemaker and LSB compliance, all the LSB init scripts that you would run with Nagios, like NSCA, Nagios, those things, they all have to exit with certain exit codes for Pacemaker to understand what that init script is doing. And just out of the box, the Nagios stuff doesn't do that. It's really easy to change. Like once you Google that page and you find out what exit codes need to happen at what point, it's super easy to change. It's like a 5-minute thing to do them all. So then the question comes into like, well, what do we replicate? What do we need to share between our two nodes to maintain consistency and that we can get up and running very quickly? And you can kind of go a couple different ways with this. There's a couple different trains of thought. We decided to go with the bare minimum to replicate. Like we only want to replicate only what we have to get everything up and running on our other node if we have to fail over. And the first thing that we're going to replicate is basically our host and service files, or configuration files, and then like any multi-check files that we might have set up, or web inject files, things that are very specific to our hosts and services. And we also replicate our RRD files that PNP for Nagios makes for us, so that any of that trending data that we collect gets saved, and then we don't lose anything in that switch. The other big thing is Nagios log files. We share those, so that we don't lose any of that historical data when we fail over to the other node. Another big one is the retention.dat file. That's the thing that's going to keep all of the current states of your services and hosts, so that when you fail over, you don't lose any of that or any of your acknowledgments or any of your comments or anything like that. So basically, when you fail over, you have an exact copy of what you had on the other node at any given time. And finally, I have mail queue. This is kind of like, I don't know, it depends on your setup. You may need to do this, you may not need to. So I just threw it in there. So what do we do with everything else? Everything else is actually, we do our own packages. We basically maintain our own set of RPMs. And the reason that we do this is for one reason is it lets us be able to update one node at a time, right? So let's say we want to update to the newest Nagios release. And we've tested it on our staging box and everything looks good, but when we go to production, we still want to do it in like a method that isn't going to completely destroy us if something terrible goes wrong. So we're able to update Nagios to the newest release on our first node. We find out that there's a problem. Okay, well, if we can't correct that problem very quickly, we can at least fail over to our other node and circumvent that problem and then fix node 1 while it's not part of the cluster, while it's offline. And node 2 is now taking on all the responsibility. The other thing is packages are usually easy. It's easy to roll them back. Like if you use RPMs or anything like that, you can yum install something, and then you find out that it didn't do what you wanted it to do. You can just do yum downgrade very quickly. Kind of gives you that capability. The other thing is they kind of have their own. They have a decent version change management built into them. I mean, it's not great, but it's something. The other thing is doing packages gives you a consistent build process. You're not like tarballing and untarballing things and writing shell scripts or something. You have an RPM and you're able to build it, and your patch is always going to be there. Last thing on the list is we actually use NDO and MySQL, but that we actually host that on its own separate HA cluster just for NDO and MySQL. So again, more about the RPMs. We build and maintain our own, and the other big benefits to it is it lets us configure everything to our liking. We don't use Nagios the same way as maybe some other people do, and we like to customize it. We like to tweak it. That's why we love Nagios, because it's just like something that you can change very easily to how you want to use it. And it also lets us update at our own pace, right? We're not just because we don't go out to like Apple and get some RPM and we have to wait for them to update their stuff. We want to be able to update and do whatever we want to them whenever we want to do it. We don't have to be at the whimsy of some other maintainer or something like that. And everything that we do with our RPMs is actually controlled through SVN. And then we have a post commit that then builds everything and updates our repository. So it's easy. It's after we've built our new packages, we can just go out to the servers and just do a yum update and get to the newest stuff that we just pushed out. And I have to say that this part of it was a lot of upfront work, but it was worth it in the long run. So then you might ask yourself, all right, well, we've done all this work. How has this helped you in like your experience? And we've had this system for about a year. And like in what cases has this helped you? And in that year, we've been able to update, repair, and do stuff to our nodes without having any significant downtime to Nagios. We've had hardware failures in our servers. We've had to do upgrades to the hardware to our servers, all without any downtime, right? We can do one node at a time, failing over, without any problems. The other thing is, updates to the OS, things like that. Recently, we wanted to update to the latest Nagios release 3.4.1 because it had some bug fixes that we liked. And then we found out that it created more bugs. So we immediately had to patch, go to the Nagios tracker, get a patch, and apply it to our RPMs so that we can avoid any issues. And finally, my favorite is the CGI pages of death. We had someone in our company install one of those Chrome Firefox plugins that lets you like get data from Nagios. And the way it does that is it goes out and it pulls down the CGI pages for Nagios. And for many of us know those CGI pages are super CPU intensive. And we have a lot of hosts and a lot of services, so it started to pull down thousands of these all at the same time, basically killing our node, our node that Nagios was running on. Pacemaker saw this. He was trying to monitor Nagios at the time, right? It was trying to make sure Nagios was up. The CPU was so hammered that it couldn't, and decided, okay, I don't know what's going on with Nagios. I'm going to go ahead and fail over now. And by that time, the person had realized, oh shit, like I just broke Nagios, and stopped the plugin he was running. And this all happened without any intervention by any human at all. Like we were able to, node 1 had died, failed over to node 2, and we were able to get everything up and running without any problems. So there are some cases that this doesn't solve every problem. Like there's still holes that you have to watch out for. And the biggest one that we run into is configuration files and restarting Nagios. There's always the chance that there's a problem with your configuration files for whatever reason. We have a lot of ways that stuff can get added and deleted from Nagios. So the biggest thing we run into is people restart Nagios and there's some kind of configuration file problem and Nagios just doesn't start, right? That has nothing to do with the cluster or anything like that. That's just something the cluster doesn't account for. And we continually build logic around how to prevent that from happening, and we've shrunk that hole, but it still exists. We use Nagios QL to do a lot of our configuration stuff, and it does do backups of what has changed when you do configuration changes, but it's not really the best. You still kind of got to comb through the backups to figure it out. But another thing that I can recommend is 2 is better than 1, definitely. If you can set up like a staging or a development setup that's as similar as you can get to what you're going to run in production, and you do all the things that you would do in production on that staging or development set of servers, it's definitely going to let you catch a lot of problems before you introduce them into your live system. I mean, most of the stuff that we've caught is all through like our testing environment. So I highly recommend doing that if it's possible. Obviously, since we're talking about a monitoring system, how do you monitor your cluster? How do you make sure that it's running well? These are all things that I found on Nagios Exchange, and they all worked really well out of the box. I think the only one that I changed a little bit was the check CRM stuff. That just the output, like it didn't give me the output that I really wanted to see. But check CRM will go and it'll pull down the cluster status of how things are running. If there's any failed resources, if there's any failed nodes, it'll let us know that. The other one is check DRBD. This will make sure that DRBD is connected, it's replicating, everything's up to date. There's nothing wrong with the synchronization between the 2 servers. And the final one, since we use Heartbeat for our messaging layer, we do the check Heartbeat link. It'll basically make sure that both links are up and running and everything's communicating happily, and there's no problems there. Some of the gotchas that we've run into with this system is we found that RPMs and symlinks are a bad idea when you're doing an HA solution. Basically, what we were doing before is we would symlink where Nagios would normally put its configuration files to where we're going to mount our DRBD. But the problem is on your secondary node where DRBD isn't primary and isn't mounted, that's a broken symlink. So then when you go and you update an RPM, it's going to wipe out it's going to wipe out your symlink for you, and then if you ever fail over, it doesn't work. It's a bad day. The other big thing is once you start putting all these Nagios resources into Pacemaker and having Pacemaker monitor them, you have to do everything through Pacemaker. You have to start and stop everything through Pacemaker. You have to restart through Pacemaker. Otherwise, if you restart or start or do anything outside of Pacemaker and it's monitoring the same things at the same time, it's going to get angry. It's going to be like, well, what's going on here? Why is this stopped? You know, what happened here? And it might cause it to fail over when you don't want it to. So we get to the part where we want to make things run fast. And every time you talk about running fast, you kind of have to give some stats. Fortunately, my company is privately held, so they wouldn't let me give you exact numbers on how much we work with. But we do an average of like 70 checks a second, and we maintain a pretty good latency. And most of our checks are active checks that we do 5-minute polling periods. And our hardware isn't really that great. We actually run on some pretty dated hardware, in comparison to what you could buy today. But we had to do a lot of tuning to get there. And it's basically like the laundry list of the things that we went through. And most of the stuff is stuff we learned from last year's conference, and stuff that we kind of just picked up like here and there on the mailing list or on the internet. And some of it gives you a lot more performance than others. I have some images a little bit later to kind of give you an idea of like which ones are really good and which ones are like super good and which ones are cool. But just to go through, like obviously one thing that you'll hear probably at this talk and any other talk, and if you look for the internet about Nagios performance, setting up a RAM disk is probably the biggest performance increase that you can get. Putting all your check results your check results queue on the RAM disk. If you run PnP for Nagios, putting its queue on the RAM disk, any of the objects.cache and status.dat on the RAM disk is going to increase performance a ton. The other thing is we use NDO utils. If you cannot use NDO utils, I would recommend not using it. It can be a significant slowdown. But we basically started to use NDO utils with the asynchronous patch. Basically, it uses the IPC queue to just buffer all the stuff that it would normally write. Instead of being synchronous, it's now asynchronous. It goes much faster. And this patch was actually built into version 1.5 of NDO utils. So if you get the latest version, you actually have this already. The other big thing is if you're using NDO utils, you definitely want to limit what you send to NDO utils. Just out of the box, NDO is going to send almost all the data that Nagios can collect to your MySQL database, and chances are you don't need it. So trimming down what it's actually sending is going to help a lot. If you use PnP for Nagios, using bulk mode with MPCD mod is a huge benefit. If you use PnP for Nagios and you don't have rdcache.d or rdcached, I would recommend putting that in there. It definitely helps with I/O. We found that restarting Nagios through the external command file that Nagios makes available, which is what Nagios QL uses by default, eventually resulted in higher latencies that we were seeing. I don't think we ever determined why. We just found that it did. And then the rest is kind of like the stuff that you'd find on the Nagios tuning pages that come with the Nagios documentation, right? Like turning on large installation tweaks, disabling environment macros. We did a lot of trial and error with the scheduling and Reaper frequencies to try and get it to run as fast as it possibly could. Did a small amount of check optimization. Basically, we just looked for Perl scripts that were just using 100% CPU. Not a lot there. But the one thing that I have to say is, I think this might be the first thing on the tuning page, is you have to measure what Nagios performance is before you can increase performance, because you don't know if you're making a change, what impact does that change have? That helped us significantly, as you can see. So this is a picture of us a little bit about the same time a year ago. We had our Nagios install, and we were kind of bumping along for a while until the end of October, beginning of November, when we switched over to our new system, and our new system implemented a RAM disk, NDO async patch, plus our rdcached. You can see before that, we were spiking into like the 60, 70 second latencies. We were all over the place with latencies as far as how fast our active checks were running. It's pretty abysmal. As soon as we switch over to that new system, you can obviously see at the beginning of November a dramatic decrease in latency plus a ton more consistency in what you're getting. So huge performance increase just with those 3 changes. The next thing that we found, okay, well, we're good now. Like, we're down to 3-second latencies. So, like, we're much better than we were before, but we're still seeing these spikes in latencies that would kind of grow after we do multiple restarts. And we found that, okay, well, let's not restart through the external command file. Let's not pass it that restart command that Nagios QL might do normally. Let's just do a full-on restart through Pacemaker every time we want to do something. And again, obviously, you see a dramatic decrease in latencies down to sub 1 second, and a lot more consistency in what we were seeing. For those of you that do a lot of passive stuff, this is the benefits to switching to NSCA 2.9, which does all of its stuff through the check results queue now instead of doing it through the Nagios command pipe, which is a pretty big bottleneck. And this is kind of an overview of our 1 year's progress, going from like, oh my God, really bad to okay, much better to really great, and I don't have to care about it anymore. This is kind of how we run now with pretty decent latencies, and we do pretty decent amount of RD updates every 5 minutes. So definitely come a long way, and this conference and talking to people was probably the catalyst for that. Definitely. If we hadn't come to this conference, which is, just so happens to be right around the same time that we did this last year, we'd probably be still in the same place. So, and I think that's it. So I think, how much time do we have? 11:20? About 10 minutes? 10 minutes? Okay. So if anybody has any questions? Sure.
Excuse me, just 1 second. I want to make sure we get you on the mic so everybody can hear the question.
Hello. Cool. You mentioned the AJ cluster, the MySQL cluster. Can you tell us how do you deal with the high availability of MySQL database?
I mean, it's pretty much the exact same. We have MySQL writing on top of a DRBD disk, and then we have Pacemaker controlling it, and then we have NDO2DB, the process that collects all the data that NDO will send. So those are basically our two resources that we run, and then obviously like the DRBD file system and a virtual IP that floats between the 2 boxes. So we basically mimic what we have here.
Have you ever had to recover DRBD installation?
The worst thing that can happen with a DRBD installation? Is that what you're asking?
Well, if you had any problem with DRBD, as in the DRBD installation failed to actually, replicate the data correctly.
Right. Yes. Not on this. We do DRBD clusters for our clients as well, and it's happened there. What happens is somebody will do something stupid, and they'll try and make the secondary primary at the same time. And DRBD is really smart about that, and it'll be like, okay, like we now have a divergence in data. Like this one has data different than this one. It'll basically, what happens is it's called split brain the cluster. So then you basically have to manually intervene then. There's no way to, there is some stuff that you can try to do with DRBD to try and take care of that on its own, but I would recommend doing it by hand. And then you basically say, all right, well, the data is different. We're basically we're gonna choose that this data is our now current data. Let's sync it back over. That's probably the worst thing that can happen, is the split brain. We haven't had, so DRBD does a really good job internally of making sure that the data on one node is actually the same on the other node. And you can do like daily consistency checks as well to make sure that that's the same way. Like it'll do like a checksum of data and stuff like that. But no, we haven't had an issue where like magically the data that we had on one node wasn't actually on the other node, and there was like there was a synchronization problem that DRBD didn't tell us about, right? It would always tell us about it at least. It'll definitely run into problems. You'll have problems, but it's always very good about letting you know that there's a problem. It's not just some like hidden issue that you find out on the worst day ever when everything fails over. So.
Good morning. You talked about the CGI user who was blocking your first node, then you switched over to the second node, and the CGI user stopped his script.
Yes.
What if he didn't stop his script? Wouldn't that kill the second node too?
Yeah, probably. And it probably would have tried to fail over again to the other node,
Yeah.
and then again, and then again.
So it's not really a solution for that kind of problem.
It is not. I mean,
You should shoot
really,
the user.
like I said, this isn't a solution to every problem. There are still holes. Like if someone, we're basically DDoSing ourselves, right? When that happens, right? Like how do we prevent that? I mean, we never really designed it. We never really thought like, oh, what if we DDoS ourselves? You know, how do we fix that? It was more like, okay, well, we really want to fix. Okay, if the hardware goes down, you know, we want to be able to fix that. If we want to do maintenance, how do we fix that? You know, those were the things that we wanted to fix. We weren't really. That was just a scenario that happened that was interesting to talk about, but it definitely could have been worse than what it was, for sure.
Okay, thank you.
I was just curious if there might be any major pros and or cons for the pacemaker DRBD approach contrasted with the VMware vMotion.
I don't know. Pros or cons with VMware vMotion? I mean, I can't think of any. I mean, I guess you're building in more redundancy there somehow. You know, just by using it. You're
More redundancy with the VMware option?
What's that?
More redundancy going the VMware route?
Yeah, I guess maybe because you can get, you know, since we run a dedicated hardware, we run a dedicated hardware for a specific reason. And that's because in our experience running Nagios on virtual machines, like the performance isn't as good when you go virtualized. But if you did go virtualized, you know, and you did have like a VMware cluster, you know, vSphere running and all that, like I guess you could get your boxes back online much quicker than if you had a hardware, like if you had a major hardware failure or something like that. I mean, you're kind of doing that, but it doesn't. Other than that, I can't really think of anything.
Okay, thanks.
Yeah, I mean, like I said, in our experience, running Nagios on a virtualized machine, when you start to get to a larger amount of servers and services, you just start to see like a decrease in performance. So that's mainly why we did pacemaker.
Yeah, we're looking at that, and we get around that, the whole performance issues with Nagios on a VM by running external workers on dedicated hardware.
I see. So you do like Mod Gearman on?
Yeah.
I see. Okay.
If I may comment on the last question here. If you ever experience that you lose your sound with your Nagios installation on, you're quite blind on that one. So having Nagios on a separate physical box, disparate, there's a way.
Can you speak up? I can't hear you.
Do you hear me? Okay.
Yeah.
No, that's better.
Okay.
I go back. If you ever experience losing your SAN with on your VMware farm with Nagios on it and trying to find out what's happening in your environment, you decide afterwards that you go ahead and install Nagios on a physical server, separate hardware from the rest of your environment. Learn the hard way.
Yeah.
Any additional questions? Going once. Going twice. All right, well, if anybody would like to speak with Andrew, he will be here the rest of the week. How about a nice big round of applause, ladies and gentlemen?